What's going on, guys? Jonathan here. So in this video, we're going to use SKLearn, Python, and this thing called the k-nearest neighbors algorithm to perform some machine learning on a data set. And I'm going to tell you basically, something I wish I was told a while ago when it comes to machine learning is, and that's, how to take sample data, identify the target variable, which is, in this case, it's making a purchase, and creating a model and feeding into that model data that could, give an output that, depending on the situation, you can make an inference about to predict the target variable. I'm just choosing my words lightly here because it's all, this is all just hypothetical. So there's a bit of interpretation to it, but let's get right into it. I ask that you subscribe to this channel if you get use out of what I'm about to give to you. Hit the subscribe button, or if not, just hit the like button. So let's get right into it, and I'll show you the sample data first. So here it is. We got these columns: age, income, student, credit rating, and buys computer. So this is our sample data. We're going to split out buys computer and make that our target for this algorithm and model prediction. And we're going to feed in, and we're going to feed into it these four, which is age, income, student, and credit rating, to predict the fifth. Okay, so let's get right into it. Let's start coding up. So import pandas as PD from sklearn.preprocessing. Import the label encoder from sklearn.model_selection. I'm just going through my notes here because it's kind of hard to remember all this stuff. SKLearn from SKLearn. We'll just start over there. From sklearn.model_selection. Import train test split from sklearn.neighbors. Import k-neighbors classifier. Yeah. So, and then we're going to load in our data. Load the data. df equals pd.read CSV, pass into a sample data. Okay, then we're going to encode the categorical variables as numerical values, which is going to be L equals label encoder, df of student, so student's the first categorical variable. df of student equals le.fit transform df of student. We're gonna copy and paste this over. df of credit underscore rating equal le.fit transform credit rating. Okay, and then df dot buys underscore computer. So now we've done this transforming, making sure that these things match up exactly. Student, credit rating, buys computer, categorical to numerical values. And then we're going to split the data into features, X, and target, Y. So Y is what we're going to predict. That's the target. And then the features is everything that's going to be fed into the model to make that prediction. So X equals df.drop. And we're just going to drop out buys computer. Axis equals 1. We're just going to drop that out of the data frame and then load that in there, and then load it into X. AXIS equals 1. Why the heck is that? X equals df. That's it. it's df dot buys. So you see what we're doing here? We're just taking our data set and splitting it into X and Y. Simple enough. And then we're going to split the data into training and testing sets. So you better get used to this because we're going to do it a lot in machine learning. X underscore train, X underscore test, Y underscore train, Y underscore test equals X train X train Y train equals train underscore test underscore split X comma Y comma test underscore size equals 0.2 comma random underscore state equals 0. Right, that looks good. And we're going to train the KNN model. Where it's KNN equals K neighbor classifier. And then N underscore neighbors equals 3. KNN dot fit. And then we're going to fit X underscore train. Comma Y underscore train. Alright. And we're going to test the accuracy now of our model. And this is going to give us an output. Accuracy equals KNN dot score X underscore test Y underscore test. And then we're going to say print accuracy and do a colon 2f dot format and then pass into it accuracy. And let's just run this, test it, make sure everything works. Invalid syntax, df dot, should be no dot there. Running, running, running. We have one small error here. Just LE equals label encoder. Missing one required position. df underscore credit rating equals LE dot fit transform. I'm missing that. Yep, okay, there you go. Now there's the accuracy. 0.75. So this model is able to predict 75% of the time the target, which is buys a computer, encoded into the number 0 or 1, and 75% of the time. And now let's feed into this some sample data. And I'm going to warn you already, it gives an error, but it's not an error because of it doesn't affect the actual output. At least as far as my debugging has told me. That could be wrong. Just sometimes these things have errors, but the code still runs. So we're going to create a new instance of the data, and we're going to call it new underscore data equals, and that's going to be 35, 150, 1, 1, which or these correspond with the 4 input values here: age, income, student, credit rating. So it's like a credit rating of 1, student of 1. So it's yes, student, and I think that would be credit rating is going to correspond with excellent. Yeah. feed that in there, and then we're going to create prediction equals to knn.predict, and I'm going to pass in the new data. knn.predict the new data, and then we're going to write out print prediction of 0. And this is going to give us an error, but it's not going to affect the actual running of the script. But you're going to see the prediction based on this info. Prediction is 1. So prediction is by yes buys computer, I think. Yes buys computer. So if we fed into it, maybe we could say maybe we can feed into it like age of 5. Then the prediction will be still yes buys computer. And that has 7.75% accuracy. And yeah, that's how you can use KNN to create a model and then make a prediction about a target variable.